So we went ahead and programmed the balls. They all fall at the same time. But before we add additional functionality so that they fall at different times, I want to go ahead and explain the way that this for loop works. Right? And so the way it works is the for loop creates a variable whose name is altitude. This name could be whatever you want, but I chose altitude. And it sets it equal to 1. You want to think about a variable as being a pocket or a cup where you can store values in it. So it goes ahead and creates it, sets it equal to 1, and then the for loop checks to see is altitude less than this number here. Okay, and it is, man. 1 is less than 33. So since that's true, it's going to do whatever we put in between the do and the end. When this finishes, it comes back up. It increases altitude by this number. Okay, you can make this 2, you can make it 3, you can make it 10, whatever you want. But I just want a standard for loop here. I want it to increase by 1. So altitude's going to increase to 2. And then it's going to come here and check is altitude still less than that number. And it is, right? 2 is less than 33. So it's going to come in and it's going to do this. And it's going to keep doing that until that condition is not true, until altitude is not less than 33. And when is altitude not less than 33? When altitude turns from 32 to 33. Because 33 is not less than 33. So that's not true. What is it going to do if it's not true? The for loop is going to not execute anymore, and the program is going to continue executing sequentially, right? Meaning they'll do 22, nothing there. 23, it's a comment. 24, it'll wait. It'll move 25, nothing there, and then it'll start this for loop doing the same thing. Okay, so that's how a for loop works. And if you want to see it graphically, it looks kind of like this. What it does is create this altitude variable, sets it equal to 1, checks if altitude is less than 33. If it's true, you execute the body of the loop. If this is false, you end the loop, right? And then after you execute the body of the loop, we increase altitude by 1, and then we check if this is true. And if it is true, we keep going, right? So it goes in a loop like this until altitude is equal to 33, and then it comes here to check. 33 is not less than 33. It's false, and we end the loop. All right. Right, and so that's what this is doing. It's executing this code here, I think 32 times. I'm not sure, we can count it out, but I believe it's 32 times. And what is this thing doing, right? So what's happening here is every part has a position property. Okay, if I go ahead and click on him, you can see here we have a position. And the position is made up of 3 numbers, right? This first number, second number, third number. The first number is where that part is on the x-axis in this world, right? You can see here we have this like green is the y-axis, the red I believe is the x-axis, and the blue is the z-axis. Okay. So this first one here is the x, where it lies on the x-axis. The second one is where it lies on the y-axis. And this one here, the third one, is where it lies on the z-axis. So that's what part.position is, right? And the type of data as it's stored in Roblox is called a vector3 piece of data. Okay, it's an object called vector3. So what am I doing here? I'm saying, okay, let's change the part's position. And let's change it by taking its current position and adding a vector 3 that we're making, a new vector 3 that has 0 on the x, 0 on the x, negative 0.3 on the y, and 0 on the z. So when we add these two vectors together, his current position with this vector that we just made that has 0 on the x and 0 on the z, that means the only part that's changing on the part's position is the y, and the y is changing from its current y position to its current y position minus 0.3. Okay, and it's doing that repeatedly 33 times. So that means the part's position is changing lower and lower and lower, but only on the y, right? The x is not changing and the z is not changing, only on the y. So it's dropping down, and then when we drop into the second for loop, it does the same thing, the same number of times, except it changes the y-axis by positive zero point 0.3, so it rises back to its original position on the y-axis. And so that's what this is how this works. Okay, this is how it makes the ball fall on the y-axis and how the ball rises on the y-axis.